So this is how the statement reads. The diagram below shows the graph of f of x equals 1 over x plus 3 minus 1. So it's a hyperbolic function. And g of x equals 1 over 2x. It's a linear function. The graph of f intersects the x-axis at A. So meaning A is the x-intercept and the y-axis at B. B is the y-intercept. They further tell us that the graph of f and the graph of g, they intersect at C and D like that. Now the first question says, write down the equations of the asymptotes of f. So we know that f is a hyperbolic function and it has two asymptotes. So it has the horizontal asymptote and the vertical asymptote. So how do we find the horizontal asymptote? It's going to be the value of q. So we tell them the equation is y equals -1. But if you must find the vertical asymptote, you are going to take your denominator and you equate it to 0. And then you say x equals -3. So this is the equation of the vertical asymptote. So we know that this is x equals -3. And here we have y equals -1, like that. So you are done answering the first part. The second part says, determine the domain of f. So what is this domain? It's just a set of all the values of x for which the function is defined. Listen to what I said. I said for which the function is defined. So if we look at the values of x, this vertical line, which we call the vertical asymptote, what is this asymptote? So it's a line that the function neither touches nor crosses. But what is important? At the asymptote is where your function is undefined. So it's undefined or it does not exist. So what am I saying? Any hyperbolic function is going to be defined for any value of x. Because if you have a look here, this function comes all the way from -infinity. It ends all the way at +infinity. However, you don't have a function at exactly x equals 3. So this function is defined everywhere except where x is equal to -3. So we must exclude the vertical asymptote from the domain. So this is how you can say it. You'll tell them that x is an element of all the real numbers because it's defined everywhere except where x is -3. So that's how you can say it. Or if you prefer, you can tell them that x is an element of all the values from -infinity up until -3. We don't include -3. And this is in union with all the values from -3 up until +infinity, like that. So that's how you find your domain. But if you had to find the range is just a set of all the values of y for which your function is defined. So you check, where does your function start in terms of y values? You can see that it comes all the way from -infinity. But now where does it end? So you can also see here that your function keeps going up. So it goes all the way to +infinity. However, there's going to be a disturbance at y equals -1 because it's a horizontal asymptote. So it's where your function is undefined. So the same applies to your range. You need to exclude the horizontal asymptote from your range. So it means your range will just be an element of all the real numbers except where y is equal to -1. But if you prefer, you can say y is an element of all the values from -infinity to -1 in union with from -1 all the way to positive infinity, like that. And if you set this, then we are very happy in the Excel. Now, the next question says, calculate the length of OB as well as the length of OA. So let's see. Now, one thing we see, if we talk about OA, for instance, OA is a horizontal distance or a horizontal length. So in order to find any horizontal length, you are going to say the bigger x value minus the smaller x value, like that. Because it's a horizontal length, you only focus on x values. However, if you look at OB, so OB is a vertical length. So because it's a vertical length, you only focus on y values, like that. So it means you need to know what is the x coordinate at A. You also need to know what is the x coordinate at B, like that. Now, we said A is going to be the x-intercept of your hyperbolic function, like that. So this means we need to determine the coordinates of the x-intercept. But we understand that at the x-intercept, it's where our y is equal to 0. That's what we know. Then at the y-intercept, it's where x is equal to 0. So I'm just going to take a picture of this because we are going to move to the whiteboard. Let's go to the whiteboard, please. Okay, we have safely arrived. So this is the equation of f of x. We said f of x is equal to 1 over x plus 3. Then you say minus 1. Now, if we must find the x-intercept, we said every time we see f of x, we understand it's y. So we let y to be 0. So it's going to be 1 over x plus 3 minus 1, like that. From here, we take -1 to the left. It becomes positive 1. And this is divided by, like that. Now, from this point, we want to solve for x. So you can decide to multiply both sides by the LCD, but I'm just going to cross multiply in this case. So I say that numerator multiplied by this denominator, that numerator multiplied by this denominator. So 1 times 1 is 1, then 1 times x plus 3 will just be x plus 3. If you make x the subject, then you take 3 to the left, it becomes negative. So this means the x-intercept is -2, meaning the coordinates of point A will just be -2 and 0, like that. So now that you have the coordinates of A, you can determine the length of OA because you understand it's a horizontal length. Therefore, you only focus on x values. So we said the bigger x value minus the smaller x value. So where did we get this 0? It's because the point O is at the origin, and the coordinates of the origin is 0 and 0. So this means the length of OA will just be 2 units, like that. And then you are set. But now we said if we need to determine the distance OB, we need to know the coordinates of the y-intercept. So we said for y-intercept, we just let x to be 0, like that. So this is just going to be 1 over 3 minus 1. 1 which I can decide to write as 3 over 3. So this is just going to be negative 2 over 3, implying that the coordinates of B are just going to be 0 and negative 2 over 3, like that. So this means if I must find the distance OB, I'm just going to say the y value at O minus the y value at B, like that. So the y value at O is going to be 0. It's the origin. And then the y value at B is negative 2 over 3, like that. So this means the length of OB is 2 over 3 units, which you can decide to write as 0.67 units, like that. So imagine giving your distance as a fraction. Well, I've never seen it before, but that's it for this one. So let's see the next question. So 6.4 says, determine the coordinates of C and D. So one thing we know is that C and D are the coordinates of the points of intersection. These ones there. So we know something interesting. We know that at the points of intersection, it's where our two functions are equal. That's what we know. So because it's where our two functions are equal, then it means we must equate the two functions in order to find the value of x. So now that we have the x coordinates of the points of intersection, we substitute both of them into any equation we prefer so that we can find the corresponding y values. And those are our coordinates. Awesome. So we are saying it's where f of x is equal to g of x at the points of intersection. But what is f of x? It's just going to be 1 over x plus 3 minus 1. And g of x is just going to be 1 over 2x. So the easiest thing we can do in this case is to multiply throughout by the LCD. So the denominator here is x plus 3, denominator is 1, denominator is 2. So we understand that the LCD is the product of all the denominators. So that lowest number possible. So in this case, our LCD will just be 2 into x plus 3, like that. So we multiply every term by the LCD. So it's going to be 2 into x plus 3 over 1. So in this case, the LCD is not divided by itself. No, it's just divided by 1 because we are solving an equation and our aim is to ensure that we destroy the fraction. Yes, that's the aim. And everything is equal to 2 into x plus 3 multiplied by 1 over 2x, like that. So what is going to happen here? You can just put a bracket there, but most importantly, this x plus 3 and the x plus 3 will cancel out. And then here the 2 and the 2 will simply cancel out. So it means for the first term, you're just going to be left with 2, like that. And then for the second term, you are left with negative 1 multiplied by this whole thing. So here you can decide to say it's negative 2 into x plus 3 because negative 1 times 2 is a negative 2. Then from this point, you need to distribute. So you're going to get negative 2x minus 6, like that. And the whole thing is equal to what? So here you are just left with x multiplied by x plus 3. That's what you are left with. Then even in this case, you are going to distribute like that. So x times x will just be x squared. And then x times 3 is just going to be 3x. Then from here, you want to write this in standard form. So you take everything to the right. But before you do, 2 minus 6 is a negative 4. So when everything gets to the right, it becomes x squared. Now, you say negative 2x. When it gets to the right, it becomes positive. 3x plus 2x is positive 5x. And then we said 2 minus 6 is negative 4. But when you take it to the right, it becomes positive like that. Yes, it becomes positive. Then from here, it's a quadratic trinomial. In order to solve for x, you must factorize it. So you say, what are factors of x squared? It's x and x. Then what are factors of 4? That add up to 5. It's just going to be 4 and 1 like that. So in this case, both our factors must be positive like that. Then here we just apply the zero factor law. So meaning x is equal to negative 4 or x equals negative 1 like that. And then you are set. So these are the values of x, or rather the x coordinates of the points of intersection. Now you must find the corresponding y values. So we want to choose an equation that is the simplest. So let's go for the linear function. So we want to know what is g of negative 1, meaning the y value when x is negative 1. So it's just going to be 1 over 2 into negative 1. So meaning it's going to be a negative half. So this means the coordinates of point C will just be negative 1 and negative half. Then we come back and say g of negative 4 will just be half of negative 4 like that. So if you put everything into your calculator, it will give you negative 2. So this means the coordinates of point D will just be negative 4 and negative 2 like that. And then you are set for this question. So let's look at the last one. So if we look at the last one, it says, use the graphs to obtain the solution to this thing. So they're saying it's 1 over x plus 3, which is greater or equal to x plus 2 divided by 2. So the first thing I want us to do is to rewrite this thing nicely this time. Nicely how? So we are going to say, looking at the left-hand side, we'll just have, right. So we'll just have 1 over x plus 3. And then we say this is greater or equal to. Now, when we get to the right-hand side, I want us to separate the fraction. So it's going to be x over 2 plus 2 over 2, like that. Then from this point, it's just going to be 1 over 2x. 2 divided by 2 is 1. Then I want us to take this positive 1 to the left so that it becomes negative. So we have x plus 3 there, minus 1, which is greater or equal to 1 over 2x, like that. So what we realize is that every time we see 1 over x plus 3 minus 1, we actually see f of x. And every time we see 1 over 2x, we actually see g of x. So what is this question saying then? Now that you've put it in this way, it says we are looking for the values of x for which f of x is greater or equal to g of x. So it means we want to know where is the function of f either equal or above the function of g. So that's what we are looking for. So in order for you to know that, I want you to draw a vertical line. So you'll just do your dotted line like this, but your line must cut the points of intersection like that. Awesome. So these are our points of intersection like that. So you have divided your graph into 3 intervals from negative infinity all the way to -4. Remember, we said the x-coordinate of d is -4. So you divided it from negative infinity to -4. You also divided it into -4 all the way up until -1. Remember, we found the x-coordinate of c to be -1. And then the last interval will just be -1 all the way to positive infinity. So let's look at the first interval, this one. So we can see that from negative infinity up until -4, the function of f is above the function of g. So meaning f of x is greater than g of x. That's what we can see. But now we see that at exactly -4, then the two functions are equal. So meaning this is the first solution. So we are telling them if they want to know the values of x for which f of x is greater or equal to g of x, we are saying the first solution is any value of x that is less or equal to -4. Because from negative infinity up until -4, the function of f is above that of g. And at exactly -4, they are equal. So we include -4. Fine stuff. What about from -4 to -1? What is happening there? So we can see that even here, but now if you have a look, because we also have an asymptote, we must take it into account. So from -4 up until -3, we see that the function of g is above the function of f. So it's not part of the solution. Oh, we actually have 4 intervals here. Fine stuff. Now, if we look from -3 up until -1, we can see that the function of f is above the function of g. And then at c, they are exactly equal. So meaning this is another interval. So we tell them that between -3 and -1, the function of f is above the function of g. So it's another solution. So we say, or it's where x is less or equal to -1, but greater than -3. So this is the meaning of any value that is between -1 and -3. But of course, at exactly -1, it's where the two functions are equal. So we include -1. But if you look from -1 all the way to infinity, the function of g is always above the function of f. So it's not the solution we are looking for. Yes, so that's it for this question. I really hope it helps a lot. So please don't forget to subscribe to my YouTube channel, Let's see you in the next video. And thank you so much for watching.